December 1972. Gene Cernan climbed the ladder of the lunar module, took one last look at the desolate beauty of the moon, and spoke words that would echo for generations. "We leave as we came, and God willing as we shall return." Then he stepped inside. The hatch closed, and for 50 years the moon sat silent, waiting. No human footsteps, no voices. Just the whisper of micrometeorites and the slow turning of the lunar dust. But the waiting is almost over. For the first time in half a century, humans are going back. This is Artemis II, the first crewed mission of NASA's Artemis program. Not a landing, not yet, but something just as important, a proving ground. 4 astronauts will climb aboard the Orion spacecraft, ride the most powerful rocket ever built, and travel 250,000 miles to the moon and back. They won't land, but they'll do something no humans have done since 1972. They'll see the moon up close, with their own eyes, and bring the rest of us along for the ride. Why now? After 50 years, why go back? Because the moon is more than a destination. It's a proving ground, a place to test the technologies, the systems, the human endurance that will one day take us to Mars. It's a symbol of what we can achieve when we work together. And in a world that often feels divided, Artemis reminds us that we're capable of something greater. We're capable of reaching for the stars. In this documentary, we'll follow the entire Artemis II mission, from the final preparations on Earth to the moment of launch. From the journey to the moon to the historic flyby of the far side. From the return to Earth to the triumphant splashdown. This is the story of the mission that brings humanity back to the moon. At the heart of Artemis II is a monster. The Space Launch System, SLS for short, is the most powerful rocket ever built. Standing 98 meters tall, it's taller than the Statue of Liberty. When it launches, its 4 RS-25 engines and 2 solid rocket boosters will generate 8.8 million pounds of thrust, more than the Saturn V that took Apollo to the moon. It's a machine of almost incomprehensible power. The 4 RS-25 engines at the base are recycled from the Space Shuttle program, but upgraded, improved, pushed harder than ever before. They burn a mixture of liquid hydrogen and liquid oxygen at temperatures so cold they'd freeze your blood instantly. The fuel is pumped at such pressure that the turbo pumps could drain an Olympic swimming pool in 25 seconds. These engines are the product of decades of engineering refinement. Strapped to the sides are the 2 solid rocket boosters, each one longer than a football field. They provide 75% of the rocket's thrust at liftoff. Once they've burned through their fuel, about 2 minutes after launch, they'll separate and fall back to Earth, where recovery ships will pull them from the ocean for reuse. Nothing goes to waste. The orange core stage is the backbone of the rocket. It holds 2.6 million liters of propellant, enough to fill 10 Olympic swimming pools. At liftoff, it weighs over 2,500 tons. Most of that is fuel. By the time it separates from the upper stage, 8 minutes later, it will be empty, falling away to burn up in the atmosphere. It's a one-use wonder, sacrificed for the mission. Above the core stage sits the upper stage, the ICPS. Once the boosters and core stage have done their job, this stage takes over, pushing Orion out of Earth's orbit and toward the moon. It's powered by a single engine, a version of the RL-10 that's been used for decades. Reliable, proven, ready for one last job before it's discarded. 4 humans, 1 mission. The first international crew to venture beyond low Earth orbit. 3 Americans, 1 Canadian. Together, they carry the hopes of not just their nations, but of all humanity. Meet the crew of Artemis II. First, the commander, Reed Wiseman, a veteran of a previous space station mission, a naval aviator, a test pilot, the kind of calm, decisive leader you want at the helm when things go wrong. He's flown once before, spent 165 days in space, done 3 spacewalks. Now he leads the most ambitious mission in a generation. The pilot, Victor Glover, a naval aviator, a test pilot, and a veteran of the space station. He'll be the one flying Orion, manually piloting the capsule during critical maneuvers. He's also making history as the first African American to travel to the moon. When he looks out the window at the lunar surface, he'll carry the hopes of millions who dreamed of this moment. Mission Specialist, Christina Koch. She holds the record for the longest single spaceflight by a woman, 328 days on the International Space Station. She's done 6 spacewalks. She's an engineer, a physicist, and now she's going to the moon. When Artemis III lands, she's in line to be the first woman to walk on the lunar surface. But first, she has to prove the systems work. And finally, Mission Specialist, Jeremy Hansen. He's making history as the first Canadian and the first non-American to travel beyond low Earth orbit. A fighter pilot, a veteran of the Royal Canadian Air Force, he's been training for this moment for years. When he sees the moon from Orion's window, he won't just be representing Canada, he'll be representing every nation that dreams of the stars. For 2 years, this crew has trained together. They've hiked through Iceland, learning to read landscapes like geologists. They've practiced emergency drills in simulators, rehearsing every possible failure. They've spent countless hours in the pool, practicing spacewalks they won't actually do, because on Artemis II there are no spacewalks. But the training builds trust, builds teamwork, builds the bond that will keep them alive 250,000 miles from home. The crew's home for 10 days is Orion. At first glance, it looks like an Apollo capsule, the same cone shape that brought astronauts home in the 60s and 70s. But inside, it's a 21st century spacecraft. Advanced computers, modern displays, a toilet, something Apollo didn't have, and enough room for 4 people to live, work, and sleep during their journey to the moon and back. Below the capsule is the European Service Module, built by the European Space Agency. It's the workhorse of the mission. It provides electricity from its 4 solar arrays. It holds the fuel for the engines. It carries the water and oxygen the crew will breathe. And at the end of the mission, it will be jettisoned to burn up in the atmosphere, sacrificing itself so the crew can come home. Inside, Orion is cramped but functional. 4 seats, 2 in front, 2 behind. The commander and pilot sit up front with a bank of displays showing everything from trajectory to life support. The 2 mission specialists sit behind, monitoring systems and preparing for observations. There's a small galley for food, a toilet behind a curtain, and sleeping bags that attach to the walls. For 10 days, this is home. On Artemis I, the heat shield performed unexpectedly, more charring than predicted. Engineers spent months analyzing, testing, certifying it for crew. Now it's ready. When Orion returns to Earth at 32 times the speed of sound, the heat shield will face temperatures of 2,760 degrees Celsius, half as hot as the surface of the sun. If it fails, the crew doesn't come home. It's the most critical piece of hardware on the spacecraft, and on top of everything sits the launch abort system. If something goes wrong during launch, if the rocket starts to fail, this system fires, pulling Orion and its crew away from danger in milliseconds. It's been tested successfully. It's ready, and hopefully, it will never be used. Flight Day 1, Launch Day. The crew straps in hours before dawn. The countdown ticks down. 10, 9, 8. The engines ignite, but the rocket holds, computers checking everything is perfect. Then the hold downs release, and 8.8 million pounds of thrust push them skyward. In 2 minutes, they're through the atmosphere. In 8, they're in space. For the first time in 50 years, humans are on their way to the moon. Once in orbit, the crew has work to do. They'll spend about 24 hours circling Earth checking every system, life support, communications, navigation. If anything's wrong, they can turn around and come home, but everything checks out. They're go for the moon. One of the first tasks is a proximity operations demonstration. The upper stage, now empty, becomes a target. Victor Glover takes manual control of Orion and flies toward it, carefully, precisely, then backs away. It's practice for future missions, when Orion will need to dock with landers and space stations. In the blackness of space, with Earth below, the crew proves they can fly this machine. Flight Day 2, the critical moment, translunar injection. The upper stage fires for about 5 minutes, pushing Orion from Earth orbit to lunar trajectory. When the burn is complete, they're committed. There's no turning back now. Earth shrinks in the window behind them. Ahead, the moon. For the next 3 days, they cruise. The routine is simple. Check systems, eat, exercise, sleep. They send video messages home, each one taking longer to arrive as the distance grows. Earth shrinks from a world to a sphere to a dot. Ahead, the moon swells in the window. By Flight Day 5, they cross into the lunar sphere of influence, where the moon's gravity pulls harder than Earth's. They're no longer Earth's children. They belong to the moon now. Flight Day 6, the moment they've trained for. Orion swings behind the moon, and Earth disappears. Communication cuts out. For 30 to 50 minutes, they're alone, the first humans ever to lose contact with Earth while so far from home. And then they look out the window. The far side of the moon, ancient highlands, basins carved by impacts billions of years old. No human has ever seen this with their own eyes. Christina Koch grabs the camera. Jeremy Hansen starts describing what he sees, the colors, the textures, the shapes. For 3 hours, they observe, photograph, record. They're scientists now, explorers, doing what humans do best, seeing, learning, understanding. At closest approach, they're about 7,500 kilometers from the lunar surface, farther than Apollo, but close enough to see details no human has ever seen. The moon fills the window, a basketball at arm's length. They're moving at 36,000 kilometers per hour. In the silence of the far side, with no radio, no Earth, no one but themselves, they are the most isolated humans in history. When they emerge from behind the moon, Earth reappears, a tiny blue dot, but growing. They're on a free return trajectory. The moon's gravity has flung them back toward home like a slingshot. No engines needed now, just patience. For 3 days, they watch Earth grow from a dot to a sphere to a world. Home is calling them back. Flight day 10, re-entry. The service module separates, burning up in the atmosphere as planned. The heat shield faces forward as Orion hits the atmosphere at 40,000 kilometers per hour. Plasma builds around the capsule. Temperatures reach 2,060 degrees. Communications blackout. 7 minutes of silence. Inside, the crew is pushed back into their seats by 6 times Earth's gravity. They can barely breathe, barely move, but the heat shield holds. The parachutes deploy. First the drogues, then the mains, and then splashdown. The Pacific Ocean, off the coast of San Diego. After 10 days and 2 million kilometers, Orion splashes down. The capsule bobs gently in the waves. Recovery divers approach in boats. The hatch opens and the crew emerges, tired, dehydrated, but alive. They've done it. They've gone to the moon and back. For the first time in 50 years, humans have left Earth orbit and returned safely. The door to the solar system is open again. But not everything has gone smoothly. On Artemis II, the heat shield performed unexpectedly. More charring than predicted. Engineers spent months investigating, running tests, building models. They ultimately certified it for crew, but some in the space community remain concerned. The crew knows the risk. They've trained for it. They trust the engineers. But the question lingers. Will it hold? In February 2026, just weeks before launch, a problem emerged. Helium flow to the upper stage was interrupted. The rocket might need to roll back to the vehicle assembly building for repairs. The March 6 launch date suddenly seemed uncertain. This is the reality of spaceflight. Problems arise, schedules slip, and the crew waits. They train, they prepare, they stay ready. But the rocket decides when it's ready to fly. Beyond Earth's magnetic field, radiation is a constant threat. Cosmic rays from distant supernova, solar particles from our own sun. Orion has a radiation shelter, a small space with extra shielding where the crew can wait out a solar storm. But they'll still be exposed to levels far higher than on the space station. Cancer risk increases. DNA damage accumulates. It's the price of exploration. And then there's the isolation. No one can rescue them if something goes wrong. No spacecraft can reach them in time. They're on their own, 250,000 miles from home, with only each other and the systems they trust. It takes a special kind of person to accept that, to strap into a capsule, watch Earth shrink to a dot, and keep going anyway. The crew of Artemis II are those people. Artemis II isn't just a test flight, it's a science mission. The crew will spend hours observing the moon, documenting features that have never been seen by human eyes. They'll take thousands of photos, record detailed descriptions, and bring back data that will keep scientists busy for years. From their vantage point, the crew can see details that satellites miss. They'll focus on the Oriental Basin, a massive impact crater on the western edge of the moon. They'll study ancient lava flows, impact melt, the difference between the near side and the far side. And they'll do it with the most powerful scientific instrument ever invented, the human eye. The crew are also research subjects. They'll wear monitors to track radiation exposure. They'll perform cognitive tests to see how deep space affects the brain. They'll provide blood and urine samples to study how the body responds to the deep space environment. Every piece of data helps prepare for Mars, for longer missions, farther from home. During the mission, Orion will deploy several small satellites, CubeSats, that will study the moon and test new technologies. Some will look for water ice, others will test navigation systems. Each one is a stepping stone to something bigger, a proof of concept for future exploration. Why does this matter? In a world full of problems, climate change, conflict, division, why spend billions to send 4 people to the moon? Because exploration is what we do. It's who we are. When we look up at the night sky, we wonder. We dream. We imagine what's out there. And then we go. Not because it's easy, but because it's hard. Because the challenge makes us better. Because the journey teaches us something about ourselves. Reed Wiseman says they're doing this for everyone back on Earth. Victor Glover thinks of the children who will watch and dream. Christina Koch remembers the girls who never saw themselves in space, until now. Jeremy Hansen carries the hopes of a nation and of all nations. 4 humans, 1 mission, representing all of us. 50 years ago, we left. We said we'd return, and then we didn't. The years passed, the astronauts aged, the memories faded, but the dream never died. And now finally we're going back. Not just to visit, but to stay. Not just for ourselves, but for everyone who ever looked up and wondered. Artemis II is the first step, the next giant leap, and it starts now. Thank you for watching. If this journey inspired you, share it with someone who needs to dream. Comment below. What does the return to the moon mean to you?